Imagine if you could fly through the solar system with your own eyes, watching sunlight dance across alien oceans, diving beneath gas giant clouds, and staring into the heart of ancient storms. For most of human history, our ancestors only dreamed of such sights. They gazed at stars and planets with the naked eye, imagining what they looked like up close. Then came telescopes, giving us a better view from Earth. But now, technology has taken us far beyond dreams. Probes, satellites, and space telescopes are bringing back real images, more breathtaking and detailed than even Hollywood could invent. From the scorching proximity of the sun to the icy edges of deep space, we now have a front-row seat to the wonders of our solar system. And today you're about to see these planets and moons like never before. Crystal-clear photos of swirling gas storms on Jupiter, rings of icy debris around Saturn, and distant moons hiding oceans under frozen shells. These aren't just images, they're windows into alien worlds. So buckle up, because what you're about to witness will change the way you see our cosmic neighborhood forever. Let's start this journey where humanity's first deep space explorers made history. In 1979, the twin Voyager spacecraft, Voyager 1 and Voyager 2, swept past Jupiter. Together, they captured over 33,000 images of the gas giant and its mysterious moons. For the first time, we got to see Jupiter not as a blurry spot in the sky, but as a detailed, living world. Voyager 1 zoomed in on the Great Red Spot, a gigantic storm the size of Earth, and showed us its swirling, chaotic patterns and stunning detail. What was once a blurry red blotch became a dynamic system of clouds and fury. But that was just the beginning. Decades later, in 2016, NASA launched the Juno spacecraft into Jupiter's orbit. And this changed everything. Juno didn't just take pictures. It peered beneath the clouds, using microwave frequencies to see deep into Jupiter's atmosphere. The images it sent back redefined what we thought was possible. Side-by-side comparisons of raw and color-enhanced images showed fine details invisible to the naked eye, highlighting hidden patterns and small-scale weather systems in Jupiter's massive cloud deck. One particular close pass in 2017 brought Juno within just 8,000 miles of the planet's south tropical zone. The clouds it captured appeared tiny at first glance, but in reality, each of them spanned nearly 50 kilometers wide and tall, casting dramatic shadows on the layers below. These aren't just clouds. Scientists believe they're made of water and ammonia ice, and they can trigger lightning storms that rival anything on Earth. One such lightning bolt, caught in a snapshot, lit up Jupiter's atmosphere like a cosmic thunder flash. Jupiter's atmosphere is nothing short of chaotic brilliance. One striking feature is the network of jet streams, bands of ultra-fast winds that race across the planet at hundreds of miles per hour. Juno caught an image of Jet N3, revealing sharp, ribbon-like structures with features as small as 2.6 kilometers across. It's like zooming into the planet's weather map in high definition. And lighting? Just like on Earth, it changes everything. In sunlight, Jupiter's colors come alive, and with the help of infrared imaging, hidden features start to glow, revealing the invisible beauty of its dynamic system. As Juno swung closer during each of its 5-week orbits, the images only got better. During its 46th pass, the spacecraft captured something truly mesmerizing: massive cyclones swirling around Jupiter's north pole. These storms have been churning for over 5 years and counting, revealing the planet's ferocious and persistent nature. And Juno isn't done. It's still orbiting Jupiter today, continuing its mission until at least 2025. Each orbit brings new insights and closer looks at a world still full of secrets. While Juno explores up close, the James Webb Space Telescope offers a different perspective, from deep space. Using powerful infrared vision, Webb showed us Jupiter in a completely new light, highlighting different layers of atmosphere, auroras, and thermal structure. It's like seeing the same painting under ultraviolet light. Suddenly, new colors and patterns emerge that were completely invisible before. These aren't just photos, they're scientific breakthroughs, revealing Jupiter's inner workings one wavelength at a time. Jupiter's many moons also stepped into the spotlight thanks to these missions. The largest of them, Ganymede, was captured by Voyager 1. It's the biggest moon in the entire solar system, even bigger than Mercury. And its surface tells a story. The darker areas are ancient, while the lighter bands are newer terrain. But that's nothing compared to the close-ups. Zoom in and you'll find ridges and grooves on the icy crust that look more like metal under a microscope than a moon's surface. Another stunning view came from Callisto, one of Jupiter's other large moons. Its surface is littered with impact craters, giving it a rugged look much like our own moon. But scientists believe its low density hints at an entirely different interior structure, possibly with more ice than rock. Then there's Io, the most volcanically active body in the solar system. In a 2001 photo taken by the Cassini spacecraft, Io appears as a tiny sphere with Jupiter looming in the background. The two may look close, but they're separated by a vast 2.5 Jupiter widths of space. Yet Io is no less dramatic, home to 400 active volcanoes and lava lakes like Ra Patera, with molten rivers flowing down its flanks. And then there's Europa, perhaps the most intriguing of them all. Juno got within just 220 miles of its cracked and icy surface. With ridges, bands, and strange dome-like features, Europa's shell tells a tantalizing story. Many scientists believe that beneath its icy crust lies a global ocean, possibly holding more water than all of Earth's combined. That ocean might even support microbial life. And as our technology improves, we may one day confirm that theory with absolute certainty. But Jupiter isn't the only gas giant with secrets. 400 million miles beyond lies another marvel of the solar system, Saturn. Known for its beautiful rings and golden hue, Saturn has fascinated stargazers for centuries. But you haven't seen anything yet. What you're about to discover will completely change the way you think of this ring giant. One of the most intriguing moons in our solar system is Enceladus, a small icy satellite of Saturn that was closely observed by the Cassini spacecraft. Unlike many other moons that seem geologically dead, Enceladus is very much alive, showing signs of intense internal activity. The moon is known for its dramatic geysers, which shoot ice particles and water vapor out into space through fractures near its south pole. As Enceladus continues its orbit around Saturn, it doesn't just leave these particles floating away randomly. Instead, they form Saturn's extensive and faint E-ring, essentially giving the planet one of its most unique and delicate features. Cassini didn't just spot these geysers from afar. It flew in close, capturing high-resolution images that offer a better look at Enceladus's surface. These close-ups show us a story written in ice, where older, crater-filled regions stand in contrast to fresher, geologically younger areas. In fact, the northern hemisphere of Enceladus is heavily cratered, meaning it hasn't seen much activity for a long time. This suggests that the surface up there has been relatively undisturbed. But when you look at images from the south, the terrain looks drastically different. Smoother, more fractured, and clearly shaped by ongoing geological processes. Scientists believe that beneath Enceladus's icy shell lies a subsurface ocean of liquid water. From this ocean, jets of ice and vapor shoot out into space through cracks in the surface known as tiger stripes. These plumes are rich in organic molecules, and scientists think they may originate from hydrothermal vents at the bottom of the moon's ocean. These vents could create the right chemical environment for primitive life forms to exist, perhaps similar to microbial life near deep-sea vents on Earth. Though we haven't found concrete proof of life on Enceladus yet, its potential makes it one of the most promising locations for astrobiology research in our solar system. Saturn's largest moon, Titan, is another fascinating world that may harbor conditions for life, albeit life very different from what we're familiar with. Titan is unique for having stable bodies of liquid on its surface, but instead of water, these lakes and seas are made primarily of methane and ethane. During Cassini's mission, it spotted dark surface features that appear to be lakes and rivers, their shapes suggesting erosion caused by flowing liquid. These liquid bodies were a groundbreaking discovery. No other world besides Earth has been found with stable surface liquids, making Titan stand out as a rare and complex environment. To help us understand what Titan's surface might actually look like, scientists have created artistic renderings based on data from Cassini. The lakes are thought to have formed in a completely alien way. On Earth, lakes often form due to tectonic shifts, glaciers, or volcanic activity. But on Titan, it seems the lakes emerge from something called outgassing. When Titan experiences warming periods, pockets of liquid nitrogen trapped within its crust can heat up, turning into gas. This buildup of pressure eventually causes the surface to rupture, creating depressions that fill with methane and ethane, forming the dark, smooth patches we see from space. Sometimes when we fly in airplanes on Earth, we notice the sun's reflection off a river or lake below. Cassini managed to capture a similar effect from much farther away. During one of its flybys, the spacecraft detected sunlight reflecting off a lake named Kivu Lakes on Titan. This extraordinary moment, captured in near-infrared, gave scientists confirmation that these lakes are indeed liquid and reflect light just as bodies of water do on Earth. What made this even more impressive was that the image was taken from a staggering altitude of about 18,600 miles, showing how powerful and precise Cassini's instruments were. But Titan isn't just home to lakes. It also hosts vast seas of liquid methane and ethane, spread across its surface like oceans. Even though the temperatures on Titan are incredibly cold, hovering around -290 degrees Fahrenheit, -179 degrees Celsius, its thick atmosphere filled with methane creates a greenhouse effect. This helps retain some warmth at the surface, despite being nearly 10 times farther from the sun than Earth. Some researchers speculate that life could evolve here using a completely different biochemistry, perhaps based on hydrocarbons instead of water. If true, this would completely redefine what we consider the requirements for life. Even with all our studies, many celestial bodies in our solar system remain mysterious and largely unexplored. They may be hiding surprises that could change everything we know about planetary science and the conditions needed for life. But among the known planets, there's one that is often talked about less seriously, sometimes even the subject of jokes: Uranus. When Voyager 2 flew by in 1986, it saw Uranus as a pale greenish-blue orb, with few distinguishing features. But this icy giant holds far more beneath its bland appearance, and new tools like the James Webb Space Telescope are helping us uncover its hidden character. Voyager may not have had the technology of today, but it still managed to capture valuable data about Uranus, including images of its faint ring system and atmospheric composition. We now know that Uranus experiences auroras, has subtle cloud patterns, and even possesses rings that are far more delicate than Saturn's but still significant. These early observations laid the groundwork for modern missions to explore this planet in greater depth. And with advancements in telescope technology, we're now seeing Uranus in an entirely new light, literally and figuratively. The James Webb Space Telescope has begun peering into the secrets of Uranus with unmatched clarity. One of its wide-angle shots beautifully captures the planet alongside 6 of its 27 known moons. But it gets even better. When zoomed in, the image reveals Uranus's faint rings glowing with ethereal light, bands of clouds, and even a striking polar cap. These observations are giving scientists clues about the planet's weather patterns, atmospheric chemistry, and internal heat. All of this is helping us build a more complete picture of a world we once thought was dull and featureless. Now let's move even further out, to Neptune, the most distant of the major planets. Known for its vibrant blue color, Neptune has the most intense winds in the solar system. Voyager 2 approached this planet in 1989 and captured a hauntingly beautiful image from 10 million miles away. It revealed a world of swirling storms, most notably the Great Dark Spot, a massive storm system larger than Earth's Atlantic Ocean. Like Jupiter's Great Red Spot, Neptune's storm is a vortex, but it's much more dynamic, appearing and disappearing over time. This alone makes Neptune an exciting object of study. The planet also features smaller storm systems, all of which are essentially massive rotating pockets of atmosphere. These dark spots move quickly across Neptune's surface, sometimes shifting direction entirely. The speed and unpredictability of these storms have baffled scientists. But what's even more shocking are Neptune's wind speeds, which reach up to 1,200 miles per hour. These are the fastest winds recorded on any planet, almost twice the speed of sound. The extreme cold and methane-rich atmosphere create chaotic weather systems that make Earth's worst hurricanes look mild in comparison. Orbiting Neptune is Triton, its largest and most intriguing moon. Unlike other natural satellites, Triton orbits Neptune in the opposite direction of the planet's rotation, a strong sign that it was captured rather than formed alongside the planet. Scientists believe it originated in the Kuiper Belt, a distant region of icy objects, and was later pulled into Neptune's orbit. The best image we have of Triton was taken by Voyager 2 from 90,000 miles above its surface. Even from that distance, Triton's surface appeared fresh and geologically active, filled with plains, ridges, and mysterious dark streaks possibly linked to cryovolcanism. This young-looking surface tells scientists that Triton might still be geologically alive. Beneath its icy crust could lie a subsurface ocean of liquid water, kept warm by tidal forces and possibly internal heat. If this turns out to be true, Triton would be the most distant known object in our solar system to maintain liquid water. That's over 30 times farther from the Sun than Earth is. A discovery like that would challenge our ideas about where water and possibly life can exist. It would expand our understanding of habitable environments beyond the traditional Goldilocks zone. Now let's return from the edges of our solar system to its blazing core, the Sun. Despite being our closest star, the Sun remains one of the most challenging celestial bodies to study due to its extreme temperatures. But recent missions have changed that dramatically. NASA's Parker Solar Probe achieved something historic by flying directly through the Sun's outermost layer, called the corona. The corona is incredibly hot, over 2 million degrees Fahrenheit, and Parker managed to capture images from within this searing environment, offering a new view into solar dynamics that were once just theoretical. The sun's outer layers behave like a giant boiling pot, with immense bubbles of plasma constantly rising and sinking. This motion creates magnetic fields and solar storms. Sometimes, the sun releases massive bursts of plasma called coronal mass ejections, flinging billions of tons of charged particles across the solar system. If these particles hit Earth, they can disrupt satellites, power grids, and radio communication. One such outburst was captured by the Solar Dynamics Laboratory, showing the sheer intensity of these solar storms. Recently, the biggest flare in years interfered with communication systems right here on our planet. Another spacecraft, the Solar Orbiter, has been providing incredible new images of the sun since 2020. It captured a stunning ultraviolet mosaic of 25 stitched images that reveal the dynamic and violent surface of the sun like never before. These close-up views show the magnetic loops and plasma arcs dancing across the star's surface. But the most detailed solar observations yet come from Earth itself, thanks to the Inouye Solar Telescope in Hawaii. This telescope can capture images of the sun so detailed that each frame reveals structures as large as Texas, showing the intricate dance of solar energy in vivid detail. In one particularly mind-blowing image, giant cellular structures are visible across the sun's surface. These granules are created by hot plasma rising from the sun's interior, cooling as it reaches the surface, then sinking back down, just like convection currents in boiling water. Other images show dark sunspots, which are cooler regions caused by magnetic activity. These sunspots can grow to be many times larger than Earth and often serve as the birthplace of solar flares and other magnetic phenomena. Every image we capture helps scientists better understand the sun's behavior, which in turn helps us protect our technology and even our astronauts. With each technological leap forward, our vision of the cosmos becomes clearer. The images captured by space telescopes and probes are not just visually stunning, they also shift our scientific perspective. They force us to rethink what we know about planets, moons, stars, and even the potential for life beyond Earth. As image resolution improves, we may soon reach a point where real photos of space are indistinguishable from digital renderings. And maybe then we'll finally come face to face with the true nature of the universe. Which of these breathtaking snapshots captured your imagination the most? Let us know in the comments. We read every single one. Stay tuned for more mind-blowing space discoveries, and thanks for watching.